Close your eyes for just a second. I want you to think about a time you forgot something really important. Maybe it was a phone number you desperately needed, a promise you made to a friend, or even just a fading goal that kind of slipped away. Today, we're diving into a really remarkable explainer based on the book Python Mindset Ladder, Book 2, Names, Values, and Memory by Ravindra Nayak. And look, this isn't about memorizing lines of code. It's actually a journey into understanding how we think.
Because let's be honest, human memory is fragile, right? We write shopping lists, we save contacts in our phones, we meticulously label our folders, and we keep endless notes. We do all of this because, well, if we don't, the thought just disappears. The actual meaning just slips right through our fingers. So what if we take a step back and ask, what if a machine faced the exact same problem? Seriously, how can a computer hold on to a thought without letting it just disappear into the void? How does a program actually capture a moment of meaning? You know, most programming books out there start with this really cold, mechanical approach. They just throw a definition at you, like a variable stores data. Boom, moving on. But almost nobody stops to ask why variables exist in the first place. Tonight, we're starting where true understanding actually begins. We're starting with memory. Not syntax, but memory.
Section 1. The Philosophy of Memory. Variables as deeply human tools.
To really understand a computer, we first have to understand ourselves. Variables aren't these intimidating mathematical objects meant to make you feel small. They are deeply human solutions to a distinctly human problem. And this beautifully brings us to our first core principle. Because memory needs handles. Think about it like this. You label a jar in your kitchen because the powder inside, the coffee or the sugar, is what actually matters, and you need a handle to find it later. You give a contact a name in your phone because there's absolutely no way you're memorizing their 10-digit number. Code is the exact same thing. It is literally just thought becoming organized.
Section 2. What a variable really is. Unpacking the 5-step life cycle.
Instead of just dumping another textbook definition on you, let's explore this like a giant puzzle. Think of a variable not as some weird technical object, but as a 5-step life cycle. First, you have the name. That's just a readable label chosen by a human. Second is the value. This is the actual meaning, the real piece of information. Third, we have memory. This is simply the place where that meaning safely stays. Fourth, recall, finding that meaning again when you need it. And finally, fifth, change, the ability to update that meaning as the real world changes. And you know, only after peeling back these 5 layers do we truly grasp what a variable actually is.
Section 3. Separating name from meaning. Now, you might be wondering, what's the actual difference between the label we write and the object itself? This is a huge breakthrough for beginners. Notice how the name, something like student_name, is just the handle. It points to the object. The value, like the actual name Mira, is the meaning. A name is like a lantern, right? Small enough to hold, but bright enough to guide the meaning through your code. The name is not the value. It simply helps the program refer to the value. I absolutely love this little poetry pause from the source material. Numbers count the steps, text remembers the name, truth lights a little window. It beautifully illustrates the 3 core families of values. Computers don't just store random variables, they store meaning, and meaning usually appears as numbers to count quantities, text to carry messages, and truth values like true or false to light a little window of state. When it comes down to it, programming is really just meaning management. Section 4. Why naming matters. The art of clear communication. Giving names to values is honestly a serious craft. Sure, a machine can run code with terrible names, but humans, we cannot live peacefully inside them. Just look at this comparison. If you see x equals 480, it's a total mystery. You have to play detective and decode what x even is. It's stressful. But if you see monthly_rent equals 480, it tells a crystal clear story. Good names tell stories. Bad names create mysteries. And that brings us to this absolutely crucial point from the book. Good code is kindness to your future self. When you take the time to choose clear names, you are essentially leaving a map for whoever reads the code tomorrow. And let's be real, very often that person is just you 3 months from now wondering what on earth you were thinking. Clear naming is the ultimate act of generosity.
Section 5. The equal sign rethought. Healing the math trauma.
All right, let's tackle something that causes a ton of anxiety for so many of us thanks to middle school algebra, the equal sign. Let's repair that math trauma right here, right now. I want you to anchor this sentence in your mind. One equal sign gives, two equal signs ask. This completely reframes the whole concept. In Python, a single equal sign is not a math test. It is simply the action of attaching meaning.
Let's break down how this actually builds our understanding. A single equal sign means assignment. You should literally read it in your head as is given. For example, daily underscore goal is given the text read. See? It just attaches a meaning. Now, a double equal sign, that's comparison. It asks a relationship question. Is this equal to that? By separating these two concepts in our heads, we completely remove the fear.
Now, let's look at reassignment. In normal math class, writing score equals score plus 1 is impossible. It breaks the rules. But in Python, because one equal sign simply gives, it makes perfect sense. Python looks at the right side first. It takes the current score, adds 1 to it, and then calmly attaches that brand new meaning to the name on the left. The meaning just travels forward in time.
Section 6. Reading code like a detective.
Okay, so now we need to learn how to actually read memory. A detective doesn't panic when they see clues. They follow them. And this right here is a state map. It's a real game changer because it makes the invisible flow of memory perfectly visible to us. We simply track the name, the value, and how it's used. So completed underscore pages starts at 0, it updates to 1, and then it updates to 2. We aren't guessing what's happening, we are actually watching the meaning move through time, recording its state step by step.
And as the author so beautifully puts it, the old value speaks once, then steps out of the frame. The new result arrives softly and carries the same name. Isn't that great? The name stays useful because it always refers to the current state of things, not some past moment that's already gone.
Which brings us, finally, to the future. We've bridged the deep philosophy of human memory all the way to computer variables. We know how to name, store, and trace meaning. But I want to leave you with this provocative thought. If a program can remember meaning, how does it use that meaning to judge, to decide, and to actually make choices? Well, think about that for a bit, and as always, keep exploring.